191 word pattern 2. Yeah, I like this problem. And because for this problem, definitely we can learn a lot of algorithms, I think. Yeah, so for me, when I see this problem, it seems a difficult problem. So we are giving a pattern, and now we need to return true if S matches the pattern, and the match is defined as, so for example, this is A, I gonna match the red, and B gonna match the blue, so it's gonna be red, blue, so this is a match. And for another one, it's gonna be ASD, it's gonna match A gonna match ASD. So the match gonna be two ways, so it's gonna be A match B, and B match A. Yeah. So if A equals to ASD, so they're gonna be 4 ASD, so it is also true. And for the next one, if this A matches XYZ, and for the next A, it should match XYZ, but it is ABC. It seems a difficult problem, but let's just continue. And now we see that the pattern slash and the string slash is less than and equal to 20. It seems the problem can be solved by brute force. Yeah, even though this is a hard problem, but when we say something like this, it is just a 20. It means we can solve it by using the brute force. Yeah, so the idea of brute force is that we are having this string S. Yeah, and we can cut it to, so for example, if the pattern's length is 4, so we're gonna cut the string to 4 parts. So for example, we can cut it to red, blue. So if this is a match, so we're gonna return true. Otherwise, if we cannot find such a cut, so we're gonna return false. Yeah, but we can also cut it from R maybe and ED, and maybe left behind maybe a B, or maybe left behind with L, U, E, etc. Of course, this is not a match. So for example, A matches R, B matches ED, and for the next A, it should match R, but currently it matches B, so this is not right. Yeah, but how can we find such a cut? And because the length is only 20, yeah, so if the cut is also 20, maybe the time complexity is 2 to the power of 20. It's not a big number, it is okay, I believe. So this means we can use brute force to find such a cut. Basically, it is backtracking. So after backtracking, we're gonna prepare an array, and inside it's gonna be subarray, and inside the subarray, yeah. And then we're gonna compare each subarray with the pattern. If that is a match A to B, B to A, so we're gonna return true. Otherwise, we're gonna return false. Yeah, so this is the basic idea to solve the problem. Now for the details, let's try to realize the algorithm. So first of all, I think we're gonna need backtracking. So let me prepare a backtrack. So inside I need a string and I need a answer. And now I want to put all the answers inside my result array, so I'm gonna prepare a result array. But how can we check that? How can we cut? I don't think this is gonna be too difficult. But before that, let's just prepare m gonna be equal to the length of the pattern. Yeah. Now we are going to uncut it. So let's just begin the backtracking. So we're gonna check the length of the answer array. Yeah. So if the length of the answer array equals to m minus 1, so it means we've already found the three parts, maybe red or maybe blue, maybe another red, but what left behind, we just need that. Yeah. So the answer is gonna append the string S, the current left behind the string S, and the result gonna append the answer. Yeah, and finally we're gonna give a return. We're gonna go for the next backtracking. Now we are going to use a for loop. So it's gonna be starting from 1 to the length of the string, and then we're gonna start the backtracking. So for the backtracking, basically there are gonna be two parts. So the first part is gonna be the string, and the second part is gonna be the answer array. Yeah. So what is the string left behind? So it is S, it's gonna starting from I. Yeah. So for example, if we take the first character, it's gonna be R, because I equal to 1. Yeah. So what's left behind is from E to the right side. It's gonna be these areas. Yeah. If I equal to 1. So, but what should we put inside? So it's gonna be the answers array. It's gonna plus string. So the string gonna be from 0 to I. Yeah. So we're gonna put the first part, this part R, inside the answers array, and then we're gonna check if this answers array equal to m minus 1. So currently m equal to 4. If it equal to 3, it means we already found 3 parts. But we still needed to put the last part inside. We just needed to use the answer append the last string, and then we're gonna use the result to append the answer, and the result will be all the cuttings. So basically this is a brute force, but we used backtracking. Now let's just call the backtrack. So it's gonna be string, and it's gonna be an empty array. And let's just check what is inside the result array. Let me just return a true or false. It doesn't matter. Now we just focus on what is the result. Let me just run it. Yeah. So as you can see, this is all our cuttings, and this is the result array. So the first cutting gonna be like, let me use this example 1, maybe R, E, D, and what left behind is blue, red, blue. It's gonna be something like that. But definitely there's one cut that meets our answers. Yeah. So if you solve the backtrack, basically you finished 90% of the problem. Yeah. So what left behind is only a check, only a final check. I'm not sure if you are familiar with this kind of check, but in Leetcode there are a lot of similar problems for checking a map A to B, B to A. Yeah. Now let's just use I think now we've already get a result. So in this result, that is our answers. Yeah. So let's just use for maybe I'm gonna use for words. So this is a words array. So inside the result, I'm gonna use a tag with this words and pattern. Yeah, so this tag is just to check the match. If they are match, so I'm gonna return a true if there is a match. Otherwise, I'm gonna return a false. Yeah. Now we're gonna focus on this check function. Yeah. So the check inside is gonna be a words. Basically, it is an array of words and pattern. Yeah. I think the check function gonna be much easier compared to the backtracking. It is just a map from A to B and B to A. Yeah, we just need to finish such kind of a map, and we need to use 2 maps. For me, I think this is going to be easier. A to B, this is B, B to A. Yeah, we just need to finish such a map. So this is A to B, and this is B to A. If it meets such a map, so we're gonna return true. Otherwise, we're gonna return false. Yeah. So the easiest way, I'm not sure, maybe I think I'm gonna prepare 2 dictionaries, because basically a map is a dictionary. So I'm gonna use maybe yeah, let me just use 2 dictionaries with empty dictionary. Now I want to check the word and pattern. So for WP, inside a zip of the words and pattern, I'm gonna prepare D1 with W. It's gonna be equal to P, and another map, it is D2 with P. It's gonna equal to the W. Now for the final return, I just need to check if this is a true map or not. Yeah. So I can use array, and inside I can use tuple. So for KV in D1 dot items. Yeah. So if it is a true map, it means another array should be the same. So here it's gonna be VK. So for KV in D2 dot items. Yeah. So for this, let me just use an example. Maybe we have a map. So for example, it is A to B, and maybe B A. It's not A. we have a map of A to B and B to C. Yeah, so this is a one map. So another map, it is D2. It is B to A and C to B. Yeah, if we have such a map, we just need to take the tuples. So KV, K and value. So in the tuple gonna be AB. Another tuple, it's gonna be BC. Yeah. So if this is a map, and for this map in Python, there's also a sequence. So this is why we can compare it directly. Yeah. So this is going to be a tuple inside an array. It's going to be a tuple of AB and BC. So for another one, we just take the values and the K. So similarly, it's also the same. It is AB and it is BC. Yeah. So it is something like that. As you can see, it's exactly the same. That is why we can compare with it directly, because in Python we can compare the array directly. Now let me just run it. What is the mistake? Yeah, I think I need to check what is the reason. Yeah, so for words in words, so if the check is okay, I'm gonna return a true, otherwise I'm gonna return a false. So this is D1 W equal to P and D2 P equal to W. Yeah, because here you see I used a VV, it should be VK for KV and K add value inside D2.items. Yeah, I think I made a mistake, I did a typo. Now let me just run it. As you can see, it works. Now let me just submit it. As you can see, it works. I think the speed is okay because here is just a backtracking, and for the backtracking, basically I need to find at most 20 cards, and the cards can be anywhere. So it is 2 to the power of 20, maybe times the length of the string. Basically, it's like 10 to the power of 6. So this is for backtracking. And for each of the backtracking array, I needed to use a check function, and this check function basically, basically the time complexity gonna also be something like 2 to the power of 20 and times the length of the string 20. Yeah, because there will be like 2 to the power of 20 strings, and the length of each of them is 20. But here inside, basically we are checking the we are checking that, and we're going to put it inside the dictionary, and we compare with the dictionary. So the time complexity going to be 20 times 2 to the power of 20. Yeah, I think that's all for this problem. It's a lot of coding, but the idea is really important. And the coding actually is not so hard to think about this kind of idea. Basically, it's a brute force. And the backtracking, and here is a trick. We need to check if the length equal to m minus 1 instead of m, because we wanted to put the left behind, what's the left behind string inside, and then we're gonna stop it. We're gonna return. Yeah. After finishing this backtracking, we're gonna just use a check function. This is just for checking the map. If A map to B, B map to A, basically it is true. Otherwise, we're gonna return false. Yeah. I think that's for it. Thank you for watching. See you next time.